It wasn't on work.
All right, well, we meet again. We're going to continue talking about the time value of money. The bulk of our time today will be solving more of those example problems. We're going to do an in-class exercise that has several more of those, and they're going to become increasingly complex to reflect the reality of the economic world that we live in. It's very complex. Just looking at some announcements, remember that you've got homework number 3, which is due on Wednesday. And on Friday, you'll have homework number 4. Homework number 4 is from the same chapter. It's from chapter 4, which is also homework 3. It's just some more advanced problems. And so I'm going to give that to you today, just in case you want to get a head start on some of these. But obviously, you've got till Friday, so don't feel like it's piled on any more than it already was before you got this. It's just, I know that some of you work ahead. Now you can. On Friday itself, you're going to be submitting that homework assignment at the beginning of class, and so I make this suggestion in the homework handout that if you'd like to have a copy of it during the midterm exam, you should make a photocopy before you turn it in so you've got it available for yourself. If you want to check your answers on that assignment or any assignment, you can stop by during my office hours, and I'd be happy to tell you if you've got the right solution. On Friday, we have our midterm exam, and we'll spend about 90 minutes doing the exam. Actually, maybe a bit less than that. Here, let me just change this. 20, I just took away 10 minutes of your exam time. But I gave you something far more precious. I gave you an extra 10 minutes on discussing the project. The project's going to be really wonderful and exciting. You're going to love it. It's going to be the best thing that you've ever done. You're shaking your head side to side. You should be shaking it up and down. But it's a great project, actually. And you're a more enthusiastic bunch than I've had previously, so I've got high expectations. So I'll introduce that after we do our exam. You'll be in the perfect frame of mind for receiving a huge project after taking that midterm exam. All right. Any questions? Content questions? Schedule questions? Life questions? No, you're right, I don't. I don't have any wisdom other than engineering economy wisdom, and very little of that. So let's begin with this example because it's the first time that we're using a cash flow diagram. The whole reason that we've been learning these cash flow diagrams since yesterday was so that we could compare alternatives. And so if we consider what's being expressed here, is which is better? Is it better to pay $18,000 in year 0 and then $34,400 for 8 years after that, and then receive $2,000? And so this looks like we're probably going to be buying some new equipment, and we're comparing the alternatives. It's probably this equipment is used to generate some revenue, but it must be the same revenue between either alternative because all we're seeing is the differences. And remember, that's one of the fundamental principles of engineering economy is just to compare the differences and ignore the things that are the same. And so whatever revenue this piece of equipment is generating is the same. So we're just trying to find out which of these two options is least costly. And what you'll notice is that you have to pay more up front for alternative 0. And it looks like in year 4 it's more expensive than before that. So it might be that it has to be somehow refurbished in year 4. And so what I'd like you to do is compare these two. We've got 10% interest that we have to discount everything at. When you're moving money from the future to the present, that's called discounting it. When you're moving money from the present to the future, that's called compounding. It gets bigger as it moves into the future, it gets smaller as it moves into the present. And so there are 3 ways that you can compare these two alternatives. You can take everything to the present, you can take everything to the future, or you can take everything to an annual cost. I think for our purposes, it'll probably be simplest if we just take everything to the present. See if you can figure out the fewest number of steps to take everything to the present. The The lazy way that doesn't require any creativity or thought is just a brute force approach. Is you do a find the present value of some future amount 8 times. You take year 1 to 0, year 2 to 0, year 3 to 0, year 4 to 0. There's no finesse in that. Work smarter, not harder. And so try and find out how can you move all of the cash flow in alternative A to year 0, and then all of the cash flow in alternative B to year 0. All right? So let's spend a few minutes doing that. You can continue working as I talk. What I want to just demonstrate is that sometimes it's useful to outline a strategy before you begin the actual calculations. And so alternative A, what sort of a strategy are you going to outline? This one's relatively straightforward. So first, we're going to do a find P given A. Find P given A at I equals 0.10, n equals 8. And we're going to apply that to the 34,400. That'll take it to year 0. And then we're going to do a find P given F at I equals 10% or n equals 8. That last 2,000 to 2,000. And maybe what I ought to do is say to the negative 34,400, just so that in my mind keep straight that's a payment. And then this 2,000, I keep straight in my mind that is a receipt. So that's the outline for alternative A. Alternative B, outline my strategy there, is we ought to have a contest of how complicated you could make it. You take everything to 1 year, then another. It looks like this annual series is interrupted, but what I can do is I can break it up so that it's still the 25,000 in year 4, but then just another amount beyond that I'll move individually. In fact, that'll be part of my strategy. I'm going to do a find P given A for I of 10% and n equals 8. On the negative 25,000, I'm going to do a find the present given a future for I equals 10%, n equals 4. So now what I'm doing is I'm moving a little bit extra beyond the 25,000 to year 0. And that is on the negative 9,400, which is the extra amount beyond 25. And then find the present value of some future amount at I equals 10%, n equals 8 on the 8,000.
Where do you get the 9,400?
It is, if you have 34,400 minus 25,000. So I want to treat this as a continuous annual series for 8 full years. And so what I've done is I've broken year 4 up into the 25,000 and then the amount beyond 25,000 that I can treat separately. it means that I can solve that alternative B in fewer steps than if I had only a 3-year annual series that I took to 0. And then I'd have to do this annual series to year 4, and then year 4 to year 0. And so it would be more steps than doing it this way. We can use this either the equation way or the table way. Table way is good for quickness.
You did split, there you go, the first part.
In alternative A, whole annual series, and I just took the 2000 to the present. In program, how many computer science program people do we have here? 2. In programming, there's something called pseudocode, right? Where before you actually start coding, you kind of outline the logic of what you have in mind. And in problems like this, it can be useful to sort of map out the pseudocode or the conversion strategy. Before you begin crunching the numbers. I'd feel better about this example if somebody asked a question. Anybody even have the slightest uncertainty they can ask a question about, so I feel like I did my job today. Throw me a bone. Everybody understands it perfectly?
No.
No.
understand.
You don't understand it, but also you don't have a question.
Well, I don't even know where to start.
Okay.
I mean, you set the problem up, and it seemed like, I mean, I don't know. Maybe
Well, let's just
it's just the way the original question was asked, where I got confused. And I was like, it was like, which one's cheaper? And then
Yeah. So which one's cheaper? So the only they look so different, right? The only way to know which is cheaper is to take everything to the same time. And so to compare them all equally, apples to apples, so they say, you have to either take everything to the present, or everything to the future, or everything on an annual basis. And so what I did is, I know I'm going to have to pay $18,000 in year 0. This amount basically is how much I would have to pay in year 0 if I wanted to open a bank account and have enough money in that bank account to pay all of those when they came due. This is that amount that would work out for me. If I was making 10% interest on my bank account, I could make a deposit of $200,587, and then that bank account is making interest, but at the same time, I'm making payments every year. And then in the last year, I actually would have only $32,400 available, but then I'd also get that $2,000, so it would all balance out. And then at the end of year 8, there's no money left. I've satisfied all that cash flow with this investment.
I understand alternative A, alternative B, where you split it up.
Okay.
Then N equals 4 is what I would.
All right. So I want to, let me raise the screen. And write on the screen rather than on the projector. Or I'll write on the whiteboard, not the projector screen. So what I'm doing is I'm saying, treat year 4 like the part that's 25,000, and treat it like the part that's 9,400. All right? And the reason why I do that is so that I can treat all of these as part of the same annual series. Because if I didn't, like if I couldn't treat this like one continuous annual series, what I'd have to do is I'd have to move this block to year 0, and then I'd move this block to year 4, then I'd move everything from year 4 to year 0. And I mean, I could do that, but it would be one additional step that I save if I don't.
Okay, thank God.
Charles, how do you feel about all this? Okay. Your feelings are good? Aaron, any questions?
Good.
All right, well, you're going to get a lot of practice. But let me now show you the brute force dumb approach that I told you has no finesse. We can use the brute force dumb approach when we've got a computer program that doesn't mind repetition. And luckily for us, we do. Excel doesn't mind repetition in the least. In fact, it relishes repetition. So let's see if we can set this up the dumb way. So I'm going to put in what our cash flow looks like. We've got interest rate is 0.1, 10%. And here I'm going to have the year, and then as given. What this basically is future values. Okay, and this is, next to this, we're going to convert it to present value. So in alternative A, we had your 0, 1, 2, all the way through 8. And the amounts were negative 18,000, negative 34,400, and that went all the way, except for then in year 8, what should I put for the year 8 amount? 32,400. That's the net difference. The net is negative 32,400. Okay, so this is my cash flow. All right. So present value. Do you remember what the formula for present value to find a present value of some future amount? If you didn't memorize that, turn to the equation packet that I gave you. So what we're trying to do is we're doing a find P given F. So a P to F.
1 plus I to the negative n, or quantity.
1 plus I to the negative n. Right. Given F, find P. So 1 plus I to the negative n. So the formula we're going to do is 1 plus I to the negative n power. And so the present value of 18,000 in year 0 is the amount times 1 plus I, 1 plus I. What should I do right now that I've just clicked on that cell?
Should lock it.
Yeah, I should anchor it with the dollar signs, and what anchoring it with the dollar signs will do is it'll ensure that when I drag that cell down, it doesn't start looking in the wrong place for the interest rate. If I didn't, when I drag that cell down, then it's going to, when I drag that down here, it's going to be looking in that cell for the interest rate, and that's not where the interest rate is. It's always in B1, so I'm going to push F4. F4 will anchor it, both down and sideways. So 1 plus I to the power of negative n, so negative this. Should I anchor that?
No.
No, because I want that to change as I drag it down. Wow, $18,000. Why didn't it change? Because it's already in the present. So $18,000 in the present stays $18,000 in the present. So if I drag that down, it's going to find the present value of all of those amounts. Why does it keep going down, Charles? Why does it keep getting less and less? I thought in interest we made more money. Like I thought that that amounts got bigger with interest. Why is it getting smaller every year?
Because the n value is negative.
All right, so from a numerical standpoint, what you're saying is the n value, we're doing to the power of a negative exponent. Okay, so quantitatively that's correct, but from a money standpoint, why is it less? Conceptually, in terms of finance.
It's reverse inflation.
Reverse inflation. So what I said before is that when you have, when you're taking present money into the future, it compounds and it gets bigger. But when you're taking future money to the present, what we call that? Discounting. And so essentially, what this says is that how much would you have to put into a savings account if 7 years from now you want to have $34,400 available? How much do I have to put into a savings account now to make that happen 7 years from now if I've got 10% interest? I have to put in $17,653. So the reason why it keeps getting smaller is, well, how much would I have to put into a savings account if it's going to be in 3 years that I take out that amount? You have to put in $25,000. So it's less for the longer time because it's been growing longer. You know, more of the amount that you're going to withdraw is interest instead of the principal that you deposited. And so it keeps getting less and less each year because you don't have to deposit as much in the present in order to cover a future payment. if it's a long time. That's why you should start saving for retirement as soon as you can. My very first paycheck when I graduated from college and got a job, I sent some of that off to Scottrade and opened a Roth IRA. You really ought to do the same thing. We're going to have an activity later in the semester where you calculate how much money you need for retirement. You're going to be shocked. Charles won't be shocked because he's already seen that activity. The rest of you are going to be shocked. All right? Any questions so far, what we've done?
So you're telling me that Social Security's not gonna cover it?
Oh, I'd never say something that bold. But I know you're going to want to live large. So you should have both your IRA and your Social Security. And then you can live large. Or if by some strange twist Social Security is not around, you're still covered. Okay, so this is, why do I call this the brute force approach?
Because it's repetitive.
It's repetitive. It's just taking whatever year it is to the present individually. It's not combining anything along the way. And then how do I find out the overall present value of all that? Just sum it up. So at the bottom here I'll say equals sum and then highlight the range that I want. So negative 200, 588. And I hope that's what we found the equation with. It's pretty close. It's better than what I had before, because what I had before was based on the table method, which usually only has 4 digits of precision. And this has, what did we find the other day, 13 digits of precision. Okay, so that's alternative A. And we can compare that to the cash flow from alternative B. So we had both a given amount, and we want to find the future value of that. Okay, so in cash flow B, we were paying negative 60,000, and then negative 25. That continued for a couple of years. In year 4, it was negative 34,400. This can be a way for you to check your homework. You know, you're supposed to do it the sophisticated way of combining things, and I don't mind if you check your work using the brute force approach. All right, so I'm going to format that as currency. That's my own little preference there. And then to find the present value of it, again, I'm going to apply the same formula. Equals the amount times 1 plus pi anchored to the power of negative n. So in year 0, it has to travel 0 years to get from that year to the present. N sometimes will be a little bit different than that, depending on if we're doing a present to the future. Actually, n won't just be the year. I'll show you that later. Sometimes n that we use will be however many years it was minus n will be what we'll take to the exponent there. But more later on that. So we'll drag this down. So Cecil, could you please explain why I only have to have, why it's 12,000 here for 25,000, but it's 20,000 there? Just in conceptual terms, why it's less?
Because it has to travel further.
Okay, there's more time for discounting. And Evan, how would you explain what this $12,000 is in real terms? What does it mean?
It's the amount that if you put in the present,
Okay.
that it would gain, it would become 25,000.
It would become 25,000. I'm glad you corrected yourself, because you almost said it would gain 25,000, but the gain is going to be about, the gain will be 12,170. So there's going to be some interest and some principal, but it will become, in whole, after 7 years, it will become that amount. So another way that you could phrase it is the present value of $25,000 at year 7 at 10% interest is $12,829. That's the present value. Another way of saying it is the future value of $12,829 after 7 years at 10% is $25,000. We can say the inverse back and forth. So again, we'll do the sum function equals sum. All right, and that is about what we found using the factor technique. And so alternative B is better. It's less costly, assuming that they both generate the same cash flow in terms of revenue. So any questions about that? All right. Let me show you 2 other shortcuts against my better judgment. Okay, one of them, instead of typing in this formula, there's got to be a better way, right? So what if we said equals PV for present value, and then it starts prompting us for what we should enter. The rate, well, the interest rate is 10%. The N is year 0. And now here it's giving us 2 options. You can either enter a payment or a future value. And so we're finding the present value, and it's saying, so is this a find the present based on A, or is this find the present based on future? And so see how the next thing it's prompting me for is PMT. I don't want to click on this, this future value as a payment. So I'm just going to say comma, comma, so that it thinks, so it knows there's no annual payment, that what this is actually is a future value. So I'm going to click right here on the future value, and then I can click end. What it's asking for in type, the reason why it's in brackets is that's an optional input. That's what those brackets mean. And you can tell it if the money goes into the account at the beginning of the year or the end of the year. By default, it assumes it's going to be at the end of the year. And so I don't have to tell it anything differently because that's what my cash flow diagram shows. So I'm just going to close it out. 18,000. Now, why do you suppose it is positive instead of, what it was referencing was negative before? Well, the reason why is it already takes into account that if you have received 18,000, or, well, this negative was that you paid it, that in the future you're going to get it back. And so it already is switching the sign. And so if you don't want it to do that, then you have to put a negative value in here, override that. No, I did the interest rate. All right. And one other thing no, it's this amount. There we go. I want to anchor the interest rate like I did before. So, with any luck, nice, right? So it saves you from having to type in the formula. So what, in addition to equals PV, what other formulas do you think there are out there?
PA.
No, what would PA? PV gives you the present value of either future or annual. So that's one way to find the present value. So what are the 3 types of things? Let's look at a cash flow. Okay, you said there's future. So there can be present money, there can be future money, and what's the third thing? Annual money. Okay, so the 3 functions that Excel will let you do is present value, which I just showed you, or it'll do equals FV, future value, or equals PMT, payment. So that's an annual value.
Well, what about interest value? Will it do that?
Will it calculate the interest rate?
Yeah.
Yeah, it will. We're not going to get to that till a future chapter, though.
Okay.
That's more sophisticated than chapter 4. You're thinking big.
Well, no, it was in chapter 4 at the beginning.
Okay.
Well, I'm just straight.
To find like the internal rate of return, the external rate of return, that's the kind of interest rate I'm referring to, and it will do that, but we're going to wait to calculate those types of rates of return. Okay, so you're going to get a chance to play around with those functions, PV, FV, and PMT. And there's one last one. No, I'm not going to tell you the real full Monty. Boy, can you handle it? Are you still going to be able to do it the long way when you need to? Once I've shown you, like, it's like the nuclear option of Excel functions. It's like you push one button and the whole thing explodes. Do it?
We already let the cat out of the box, we gotta know now.
You know, there was a saying from World War I think, is like, how can the boy go back to the farm if he's seen Gay Perry? You know, like in World War I, there were all these farm boys from Iowa and whatnot that went to Paris. And like, how can you go back to Iowa after you've seen Paris? How can you go back to type it in these equations manually once I've shown you equals NPV, net present value? It takes everything to the present, and you apply it only to money that's in the future. So I'm going to do NPV. It wants to know the interest rate, okay? That's the interest rate, comma, and then all of the values. And so I'm highlighting all the money that's in the future. This is my future money. So it's going to convert all of that to the present. And then plus, that will then add on the year that was the money that was already in the present. Pretty smart, right? It just sort of automatically takes everything to the present. But it's so easy to misuse that function because students are always highlighting the entire range, including the first number you put in there, it assumes is the first year in the future. This is not something you apply to money that's already in the present. Equals NPV of, at 10%, here's my range, plus the 60,000, and it calculates everything in the present. All right? So you know so many ways to solve these problems. There's the equation method. There's the table method. There's the brute force approach, typing in the equation. There's the brute force approach using equals PV or equals FV or equals PMT. And then there's NPV, net present value. All right, I know you're probably itching to try all those out. Now you know the Excel methods.
They're what, PV,
PV, PMT, and FV. I just couldn't resist telling you. It's too exciting. It's like Christmas morning, you know? You're tempted to open presents early. Those are the presents I've got to get you. Those functions. Okay? So, in the problem we just solved, each row corresponds to a year, and the n value that we use in converting everything to the present was whatever year it was. So we use the equation method, and then added up all the present values. Let's look at the actual equations. And these equations are in that packet that I gave you, also in your book, but sometimes you'll need to convert an annual series to the future. And it's really important for you to be familiar with when things start in an annual series. And so what you'll notice is that an annual series, by definition, this formula applies when the first payment is in year 1. If there was a payment in year 0, you'd have to convert that separately to the future. So if you were finding the future value of some annual amount, then you would have to do the annual series, which includes in the terminal year. And then if there was one in year 0, then you'd take that from the present out to the future. All right? So we can, with this function, find the annual amount of some future value. And you'll notice that the annual amount starts at the end of year 1. There is nothing shown in year 0. And this may seem like it's easy or unimportant, but as you solve problems with combinations of different strategies, you're going to have to be very careful that you know when to start things and what range they go through. And so it's important for you to note that an annual series doesn't begin in year 0. All right. Here we're converting from annual to the present. And the way that we do this with the Excel function would be equals PV, and then it would be that first function, you know, where I just did 2 commas because there was no payment, PMT. PMT is what Excel calls an annual series. And then here, to find the annual amount of a present value, that would be equals PMT, the payment amount that we want. And you'll see that it doesn't spread out, including year 0. It spreads from 0 to whatever years you've specified in N. That's how far it'll spread it out. All right. Let me give you in-class exercise number 7. The remainder of our time today will be working a problem that asks, what if you won the lottery?
I asked that myself every Friday.
What if you won the lottery? You won $120 million. And this is real. There are companies out there who will buy your lottery winnings from you. They'll say, well, you know, when you win $120 million, actually, you don't get it all at once. They spread it out over 20 or 30 years, depending on the state, and because it's cheaper for them that way. They say you won $120 million, but actually you won less than that, because at the end of 30 years, you know, however much you get every year won't be worth as much in 30 years as it is now. So it's easier for the lottery company to do, for the lottery authority to do that. And so, you know, there are a lot of people who, when they win the lottery, getting $4 million a year isn't enough. They want it all now. They can't deal with taking it out over getting $4 million now and then another $4 million for the next 29 years. And so what we're going to try and do is find out what interest rate would make these 2 payouts equivalent. Either getting a jackpot of $70 million now, or $4 million now and for the next 29 years. That's in part A. And then part B is looking at an investment company that's willing to do some sort of a scheme for you. And what is included in this part B is a gradient. And so let's look at the form of a gradient real quick. All right. The way that a gradient works, and this we'll talk more about this in additional detail tomorrow, is the form of it is that whatever the amount is starts in year 2. So it's 0G, G, 2G, 3G. And so if G was 1,000, it would be nothing, 1,000, 2,000, 3,000. And so you can look in your book. There's the formula for how to find the gradient given some future or present value. But the important thing I want to mention just now is that in year 1 it's 0G, and it's not until year 2 that it's a G. So there's lots of different ways to solve this in-class exercise 7, and I'm going to let you get to it. The tablet card is open. You can verify your paper solution using the brute force dummy approach, but I'd like you to try and solve this by hand to begin. you're going to be setting up the equation method to solve for I in part A. Solve part A manually, and then I'll show you an Excel approach to do the same. Of course, it's fine to work together on this. No need for us to have it too quiet in here. Close. So the cash flow diagram is either that you get 70 million now, or $4 million in year 0, 1, 2, all the way through year 29. 4 million. So which is better? And so what you have to do is you have to take all of this to the present and see which has a bigger present. Is $4 million for 29 years plus the $4 million in year 0 more, or is 70 more? And so what we're doing is we want to find the present given an annual series. I is not known, and it is for n equals 29. Because what we're doing here is we're going to say it's $4 million plus the present value of the annual series. Okay? And so what's the equation for a P/A? We turn to the packet. Okay. It is 1 plus I to the n minus 1 divided by I 1 plus I to the n. So we need to solve for I so that the ratio, what interest rate would make it equivalent? Is that the first question? Okay. If it was equivalent, then it would be like this is $66 million more than the $4 million that you get in year 0. So, like, remember, we have to compare differences in engineering economy. So would you rather, what this really translates into is, would you rather get 66 million now in year 0, or would you rather get nothing in year 0 and then 4 million for 29 years? Because the difference, we're subtracting the year 0, 4 million from that. So it's either $66 million now or $4 million every year. And so what interest rate makes those equivalent? So the ratio of we know that P to A is $66 million versus 4. And so the ratio of those is 16.5. And so if we had a table, then what we want to do is we want to look through all of the tables and we look and see where is it that the P to A at some interest rate for n equals 29 is going to be equal to 16.5. And if you look through, if you look at the packet, the equation packet, what you'll see is that they do 25 and then 30. They don't have an n equals 29 for those. And so you can't do it by the equation packet method. What you can do is you can set this equation equal to 16.5 and solve for I, where n is 29. And so if we solve this equation, I is what? So let me just start from the beginning. We have the option of taking 70 million now or 4 million now and then 29 more $4 million payments. 4 times 30 is 120 million. So, what they say is that I've won the $120 million lottery, but if I want it all now, all they'll give me is 70 million. And so my question is, it's sort of like they're being a bank. The Lottery Commission is being a bank. And what is the interest rate they're paying me if I leave it in there? Am I better off taking the 70 now, or am I better off taking all those $4 million payments? And so I want to think of it in terms of an interest rate. What I know is that the ratio of the present value to the annual amounts is 66 to 4. Because remember that an annual series doesn't begin in year 0. An annual series begins in year 1. And so I have to subtract out the 70 minus 4 gives me the 66. And so I want to find out what is the interest rate where, if you were converting from an annual series to the present value, you'd have a ratio of 16.5. So try and solve for the I that does that. solve that with a Casio? I'm astonished. These Casios have more guts than I thought. About 4%. Just a guess. Ooh, there isn't a 29 though on the table. You interpolated somehow?
Got 30, so which was close.
Okay. So now you know it's about 4%. Charles, would you be comfortable demonstrating on the overhead here how you put it into the Casio?
I don't know if I can do it again, but I'll try my best.
All right, let's give it a try. You're gonna be brave like a lion. I don't know why they say lions are brave. They're like, they've got gigantic teeth. They're the biggest one in the jungle.
That YouTube video that lion versus crocodile. Tells you what.
Such a video exists.
Yes.
So you want me to type it in?
Yeah, set it on the table so it'll stand focused. Now turn on the lamp. We'll white balance. So it looks good. I gotta go white white balance. All right.
Alligator gets
Well, let's see. There's a glare.
water.
Just
All right. Can everybody see?
no. Sorry, it's just my first answer.
I don't know if I'm ready.
So they're behind you. The formula.
Is it better now or worse? So what mode do you actually go into to start typing in an equation? How do you even tell it, hey, I'm typing in an
Type
equation?
in
16.5 then equals? All right. So there's no special equation writer mode?
I don't think so.
Okay. Alpha, okay, so x is your variable.
29, is that right?
Mm-hmm. -1. And down the denominator. I plus times 1 plus x.
Is that it?
To the 29 power. Okay, so everybody look at that. Everybody with a Casio, do the same thing. It's not enough to not be, you have to be able to solve for I. This is something you have to be able to do on the exam. I don't know how to do it on the Casio. I can do it on the HP, but we're like, shift solve is the last part.
No shift. Calculate.
Alright. And then how long did it take for it to
Long
get
time.
solution? Yeah, it's chugging away for a while. Now let's see it do that. Shift, solve. It solved for it quick because it probably had the previous answer. There it is.
What mode did you go into the?
I didn't go in any mode.
You just started typing in the numbers, right?
Yep.
16.5 equals. How do you get that dividing bar?
How do you put the equal sign?
Oh, right there under cap. Press that button.
Under calc is the divide bar. All right.
Love you, man.
Okay, one more time, fast this time.
Me?
Yeah, let's see it one more time without me talking through it. I might study the video later. A little bit closer to the center. The light is, it's either glare or too dark. We just can't win on this. Let's do a little lower, sorry. Glare. There, that's perfect. We can make a YouTube video of this. How to solve for the interest rate on a Casio FX115 ES 1495 long.
What's the new one have on it?
All right. Slow clap. You know I got a movie? All right, thank you very much.
Why don't you just pop on the 5? You actually listened during Kirsten's class over there? Did you see it that class too?
Yeah. No, that'd be easy.
Okay, I gotta look at it. But I'm anti-Casio.
You're probably gonna
You using this formula?
See, I think I got it on 1 equals.
I don't know.
Yeah,
Is there
solve
someone
it.
on this side?
Maybe,
I'm sure you can get it.
Charles will give you a tutorial. Didn't seem to work. Anybody else getting it not to work?
Well,
Who is getting it to work? Success.
that's your worst.
Aaron, did you get success?
No.
No success? What was the issue?
It gave me like 60%.
It said 60 what?
60%.
60% interest?
Something in Rome.
Yeah. Well, I'll circulate around as you continue working on it. And when you have got the correct interest rate, then try and solve part B. You've got another option here. So draw the cash flow diagram on part B and find the present value of it. And what I'll do is I'm going to put out the form of the gradient function. I'm going to write that on the board for your reference.
Did you do?
Did you go to ship solve? Did you get it to work? Why don't you both type it in at the exact same time? Let's see what you did. Set your calculators together. Math mode, yours says D. I just sat there staring at it. So you do 16.5, right?
Yeah.
I wish I could use this computer.
Is this solvent? I was looking at
Who else has a TI?
I'm trying to figure out.
Did you get a TI to work?
You said where,
See here.
tell it to, like on your exam, tell it to solve for X. You know which function.
I know how to do it on mine.
Well, I mean, what's the function called, you know?
How about
What's
yours
the-
do?
I'll show you what mine looks like. I don't think that's gonna help you because mine's so awesome it can't be replicated. How does that calculate? Well, this is the slightly newer one. The one I really like is 15 years old. This one's only about 5 years old. Okay, so when I'm doing calculations, I have numerical solver. Solve equation, and then I go into an equation writer. I think it's easier on Casio. Yeah, easier. Huh? Check this out. Check this. 16.5 equals 1 plus I.
I don't think yours never taught us that. He did not.
Yeah, he did.
To the power of n. Yes, that's right. I'm not using x. I'm using the actual variable.
I think you can use the actual variable too, I just used X for the easier.
All right. I thought you could only use the actual. Or only.
Define.
I mean, it should count, it should solve
We're having a battle of calculators today. This is a good day.
That's weird.
Did it work?
It still pops up as bubbles, I click the equals, and it pops up with the eggs.
And it did the answer?
Yeah,
All right, so I
I
go.
had the right answer.
Yeah. So I say okay, enter, variables are. If I wanted to solve for 10, I could do for 10, solve. In our case, it's 29. Okay. Solve. Boom. HPs are awesome.
How much does that calculator cost?
This one's about $90. Well, I mean, you're going to be doing your career for how long? I mean, like, spread the cost of this over an annual basis for 40 years. It's pennies, pennies. It's worth it. Okay, so you got it to work, right?
I'm still trying to figure it out.
You got it to work. How about you? You got it to work now? Let's see here.
I don't think he's got to work.
Did you work on your TI?
Did you get it to work?
On my Casio?
Yes.
Yeah.
No, I'm saying on a TI. I want the TI people to help each other out.
I think so. The YouTube video.
Come here. Thinking it's just, see, which questions are you involved in? I looked through the math and
Manual, if you want. I was gonna give you like help in there. Yeah, go ahead and take a 5-minute break if you need. If you'd like to step out for a drink of water or whatever.
I got programmed.
TI.
Yeah, I'm pretty sure he does.
You should ask him how to solve equations. Let me tell you, right?
Can we skip this?
Oh, that's part of the point of catalog. What's this? It's in catalog. It's just functions. Unless you just start typing it in, 16.5 equals. Where how do you break it? But there's got to be something that's equal. Well, you may have to wait till you watch.
Oh,
the
I
video.
got it.
All right, TI people, go to Andrew. He's going to show you how.
I don't know about, I'm on the Inspire, it's a bit different than that. I don't know, probably the same thing. I don't know if you have an install on the.
Well, certainly you can do it the dummy way, right? I mean, it's like there's probably an equation, a fancy mode that you're trying to get into. Can you just sort of go into old school mode like these ones?
No.
Did you get it? Just how would you type in like 5 minutes?
Okay, plus. Oh, this is his calculator, not bad. Don't you have to use this?
Yeah.
Okay, so now that you're in this mode, do 0 equals. Uh-huh.
Oh.
Negative 16.5 plus.
I don't mess with those things.
Now, enter parentheses. Okay, just start typing in that equation over there.
I'll show you my background.
Oh, I got it.
Yes.
Forever.
I don't know. So, too.
You know what?
Just think.
Saying negative.
Oh, there's probably an easier way to do it than I did. You see what I did?
Just did a negative.
I wasn't.
So to start on part B, once you've calculated the interest rate in part A, put this line too high, I can't show that it's a gradient, but the numbers indicate there's a gradient in there.
Okay, it starts at, now, I don't know that on that, force and multiply there times.
Right here. Yeah. So 2 new over.
Eliminates times squared.
Where's that G channel?
Now, solve it. What about the,
Oh, okay, so it's a G, so you one, nothing, and one. Okay, you said it's
but it's in there's no version, so you can't try to do like a variable. Alpha, is that mostly very small?
This is.
Yeah, but, I mean, it probably retains some of the same functionality. Is alpha solve available to you there?
I can, yes, I can do it. I'll do it.
It's terrible. You have to go to, math, and then go include
Alpha enter to solve.
I think you're headed down the wrong path with that. I think that you can probably use the very same method that everyone else is using. Everything else, not pasting in your answer, not pasting in your answer. Actually, you clear it as a word.
You always multiply the number you give by some value. You're ready to move on to, but it's not, it's a big hole, a big gap. So just like you're checking, it's
Right, so.
Zero equals negative 16. But right here, it's almost gonna stop. It's showing the multiple. That equation multiplies 1 over that.
That kind of makes sense, but what's the power of this?
Right. And you're not going to be upset.
Not
Whatever you're
31.8.
2 feet, you know. Something.
You just got room there.
Enter.
Control answer.
That's a T. Square C.
6 caps.
It's the best finger.
What?
It's the best.
A what?
It's the best calculator.
I guarantee that once it's, I guarantee it's something so simple, it's not even fun.
What's engineering? Keep it simple, stupid.
Yeah, keep it simple, or no, it's keep it stupid simple. That's the page I was on.
Okay. You multiply this by 2 million, right? Multiply this by, how many your gradients are in way 2 times you're gonna do.
It's 2 until the last one.
And then it jumps, but you have to piece it up. That's, but you have to, and you do the same thing all the way to 9. And then you have to, do something.
Andrew, I'll have to work with you after class, because I think it's gonna take some digging.
Alright.
I want to show everyone else the Excel way to do the interest rate. Okay, everybody grab a tablet, get a tablet PC.
Let's try to remember.
They've got a mouse in that box on top if you'd like not to use the touchpad thing. Okay, fire up Excel.
So, if you're doing part B by
It's
hand,
linear, not linear, section 16 to 20.
Well, the gradient ends. So that's a trick, is that,
So you gotta do.
yeah, so you use the
either you
gradient
can
line
continue
to.
the gradient through 10, and then there's an additional 2 you have to take over, or you end the gradient at 9 and take the 20 over by
Okay,
itself.
so that's why I was, so which one would you pick for the second part? All right, if you were to end it at 16 really, and bring the 20 one over, I mean, what, I know you use the gradient one, but what?
Okay, you use the gradient for all of this.
Right,
So the end would be 9,
right.
and then you do a find the present given future for the 20 with n equals 10.
Add on 10.
And then you'd add the original data. Exactly. Okay, so most of us have solved part A using the calculator. There's a way to do it with Excel. And the tool I'm going to show you is important to know for the project. Some of you may already know GoalSeek. How many people here have used GoalSeek before? 2? Man, I'm just teaching you all so many beautiful things today. You're going to be forever indebted to me when I show you GoalSeek. It's not like I wrote the thing, but I'll act like I did.
Will it make me lots of money?
It could.
We'll predict all your numbers.
Okay, so we're going to do part A of this in-class exercise. There's alternative A. And we've got the amount and the PV of amount. We're comparing alternative A and alternative B. You can type this in as I do it if you want to have this sort of like save a file of it, have it available to you as a reference when you solve homework. PV of amount. Sometimes it's just having the structure of a solution that can be helpful to kick things off. Okay, alternative A is that you just get your 70 million now. And so what's the present value of that? Equals PV at our rate. We've for this in-class exercise, I is equal to, we don't know. That is the question. So we're going to have some amount in here. Maybe it's 1%, 0.01. We're going to solve for that. So what's the present value? So it equals PV at whatever that rate is and this is N, and this isn't a payment, it's a future amount. Okay, since it's in the same year, it's the same amount. Or we can have $4 million. Times. So try using that PV function to find the PV for all those $4 million amounts.
You need to anchor the rate, right? It doesn't do it by itself.
Yes, you do need to anchor the rate.
What, can you highlight where you had PV?
What?
Where on the PV amount, can you highlight it? Like when you plug it in. Oh, there it goes.
Aaron, did you already find the present value of that $4 million?
No.
I'm using the PV function to solve this instead. Yeah, PV.
Let the prompts that come up when you start typing in the equation guide you. It'll tell you what it wants.
What's NPR?
N. Let the force guide you.
PMT's amount, right?
It would be like an annual amount. And so that's where you just need to put comma, comma, because it should be 0 for PMT. What you're actually putting in is you're putting in a future value.
For the type units, close parentheses.
For 0?
For
Oh,
type.
yeah, you can just ignore that.
Alright.
Did you multiply it by?
Oh, no, that's what it is.
Did you? Well, you don't have to multiply it, but it's not ever looking at your cash amount, is it?
No. So where would syntax cash amount go?
It goes FB.
FD, okay.
Yeah, so it's not a PMT that you want, it's an FB. So you've got the rate, the NPR.
Right there.
Yeah. Good. And so what you'll notice is that it turns red because whenever Excel does these calculations, it's finding the opposite sign. We said that this is a receipt, and so it's going to think that you're calculating the equivalent deposit. So if you don't want to think in those terms, then you just have to manually override it by putting in a negative value for the amount. And then do the same thing to the $4 million. You've got $34 million payments coming to you. Find the present value for each of them at some, if it was at 1%.
Why aren't yours red?
Because I put a negative sign in front of the amount, like
No, right then.
960, 911, or 921. Yeah. So if you want them not to be red, go into the formula and put negative D5.
Oh, I remember you talking about that.
And then drag it down.
Oh, configure some. Let's see. Oh, that's right here.
So these are all of the present value if it was at 1%. And so how much, if you wanted $4 million 6 years from now, and you can only earn 1% interest, then you need to deposit $3.768 million. Just thinking in terms of what these values mean. The present value of $4 million in the future is less. And so the interesting thing is if you look 30 years from now, well, in year 29, that $4 million they give you is really only like you're getting $3 million in today's dollars. So the present value of that $4 million is relatively low. Okay, so here's the last thing we need to do to look at alternative B, and that is add up all of the present values. So equals sum of all of them.
Including the first one?
Yes.
Okay, so that's your sum.
I want to say 30, that's what I did. I think there's more of them.
Okay, so that's something
That is money, so that you can see the comma. It helps you to keep track of the difference costs.
So it'd be better to take the 4 million.
What's that?
So it's better to take the 4 million.
Well, we're not done yet. Remember the question was, what's the interest rate if they do that? And so we put in this 1% just as a placeholder. So what we're trying to find is what interest rate makes all of this added up equal to 70 million. And so we can play around with the I, and we want them to get close together. 0.02. Is it closer? Yeah. 0.03. We're getting there. 0.04. We're really close now. The question was, what interest rate? It's sort of like receiving a certain interest rate if you go with that. So everybody play around with the interest rate a little bit. You know what it's supposed to be from when we solved it on the equation.
I forget
Okay, I've almost got it.
So first it wants to see the interest rate. Anchor as a Nope, just one. You drag it down and you bottom the next one.
0.0.
Now payment on the balance sheet, just do another comma to get out of that. Future value on the amount. You got to move the amount, so put them on.
It should be that number we found that.
24312.
Load it out with the rest of these. And ignore that last part.
Can we solve
And then drag it down.
You can if you want.
Solver? Yes. So, everybody watch on the screen, because this is like the beautiful magic here that you don't want to miss. I'll dim the lights so that the video gets this beautiful magic. Okay, so go to data. Well, just watch, and then you can do it in a bit. Data, what if analysis. I don't see enough eyes on that screen. You don't want to miss this. This is big. You have to know this function for the project. What if analysis. By the way, how far off are we? Let's say difference. So we want them to be equal. So that minus that. So this difference function tells me whether my guess is close or not. So like when I was at 0.01, I had a huge difference. 0.02, I'm getting closer. 0.03, does everybody see why I put this difference here? Is it 10%, 0.1? No. All right, so data, what if analysis, goal C. So what's my goal? I want the difference to be equal to what?
Oh,
This difference here,
zero.
it's going to be 0. So my goal is I want that cell to be 0. And what should I change around to make that happen? What have I been playing with?
C2.
The interest rate. So I'll click on cell C2. And so what I'm telling the computer is my objective is to get that difference down to 0. Because I want to play around with the interest rate. And when the interest rate changes, then all of these amounts change. And when all of these amounts change, so does the sum of all of those amounts. And the original question in part A is what interest rate makes it equal so that 70 million is the same as getting all of those $4 million payments over 29 years. And the reason why they're asking is because if you could take the 70 million and put it in a bank account that makes more than whatever we're solving, then you're better off taking the 70 million. If you can't make that interest rate, then you're better off taking the payout over time. Okay, so by changing that, okay. And what it does, really quickly there, it just played around with lots of different values of I, and then finally it found some perfect value of I that gives you 0 difference. So let me go through that again. It's data, what if analysis, goal C. I want it to have the difference equal to 0 by changing the interest rate. Okay, boom. Calculates, you see the numbers flash on the screen there. I wish you could actually slow it down because it would be kind of cool to watch it compute for a few minutes before it finally gets there. It does it much too fast, and that's the interest rate that, that makes 70 million now the same as $4 million every year for 30 payments of it. Try the what if analysis on your own machine.
He's still been done agree. We're just gonna do the 18 here.
It's not wide enough. It's so wider.
Like, I'm gonna go to 16 and then.
It didn't have enough room to show it.
Nielsen.
So I'll go through value of R. What's the difference?
Here, like do the sum of all around.
The cell that has the interest rate that I found.
Good.
Goal C is success.
One sec. Okay, so you do, whatever it is, all right, this,
Now this is sum.
Oh, you
Wasn't
put
this
it-
sum?
Yeah, that's supposed to be
So
sum.
don't say difference, call it sum.
Okay,
And then difference, so
if I spell it right.
that's okay, don't worry about the spelling.
All right.
But you actually have to put a function below it. Okay, so
Yeah.
it's gonna
All right,
be
this is
that
supposed to
minus
be a
that.
difference. Okay.
So no, you have to have the sum, and then you have to have the difference.
Okay, and sum is.
You already, okay, so you could use that if you want down there.
Okay.
So what function have you got in here? Is this
Okay, That's
difference?
supposed to be a difference.
Oh, okay, I'm sorry, I changed it. You already had sum at the bottom.
and C, okay.
All right, so you don't actually have to have another area.
All right, so what if goal C? You pick your difference value or your sum for the first value?
Difference, because you want your difference to be 0.
Okay. All right, I set that to 0. And then you pick your,
The location of the interest rate.
all right, which is right here. And okay.
Using nuclear power to pump water up a mountain during the day, you have the water go down the mountain to generate electricity, and at night is when you pump it up. Because nuclear, what's that? With goal C.
Hey, what percentage, Joey?
4.2.
During the day, what, like liters?
During the day, there's a lot of demand for electricity, so you need all the nuclear power and some hydropower. But at night, when people go to sleep, they're not using power, so you've got leftover nuclear power you can use to put it up some hills. And so the question is, how much water should you put out there at night?
Is that actually right?
Yeah. They've got one down in South Carolina, they've got a bunch of them out west. All right, you got it.
How do you get on the internet?
You've already solved it? Yeah. What about part B? If we want to double check part B, I asked you to solve it as a gradient on paper, and let's double check to see what the answer is supposed to be for that. So year, amount, PV. So you can follow along in checking your solution with Excel, part B. Did you know that Excel can detect a pattern? 2, 4, it knows the next one should be 6, 8, 10, 12, 14, 16. Wait, but it thinks 18 is the last one, but we know really it was 20. Equals PV. Okay, on this part B, I is 0.02.
Right, that's the value, so you want to say 7, so 0, I change it. I'm going to trade it, I'll trade 7.
I do, but it needs to show answers. I put it as like a 2-minute battery.
So you still want these done by hand?
Yeah, I do want you to do part B by hand. I do want to see that.
Is it alright if I was off by $97, like around?
$97, yes, that's fine.
When you say by hand, you mean using a table or?
Hand, table in this case is fine. On the exam, I'll tell you specifically if I want formula method, table method, or dealer's choice. Dealer's choice, whatever. first step to these is always draw a cash flow diagram. You should get so good, that should be your first instinct, that anyone asks you a question, your first instinct is going to be to draw a cash flow diagram. Well, what's for dinner tonight? Draw a cash flow diagram. What movie do you want to see? Draw a cash flow diagram. It works in any situation.
Can you highlight that, the function we did for pay period?
One's true, right? Babs the lead back, he goes out there, smoke breaks 30, like 45 pounds. It's a whole lot. No, you have him an hour and a half a day. I have him for 2 days. I picked that Monday, Wednesday once. He doesn't have exams on Monday, so.
The VFB by 8.8203 times 20 million on 2 million TX.
Well, what I did is my gradient went through n equals 10. It depends on if you stopped your gradient at 9 or if you went the gradient through 10. So Mark asked a question, should I multiply this 0.8203 by the full 20 million? And it depends on what your strategy is. I did my gradient from 0 to 10, and so I broke this up to an 18 million part, and then just a 2 million fragment above that. You just as easily, in this case, could have made it a gradient of 9 and then taken the full 20 million back 10 years. In the end, you get the same answer. So, what about this? Which is better? Is it better to take this gradient payout, or is it better to take the 70 million? The gradient payout's better, Because what they're doing is if your discount rate, inflation is 2%, then all of this money in the future, discounted at 2%, is like getting $89 million now. And so what this company is saying is they're saying, well, we'll take your $4 million every year, and instead of taking $70 million from the state, this company is saying, take $89 million from us. So they must want to have the benefit of that $4 million every year. Somehow that fits with their needs, to have that constant income. They're willing to pay a lot now to have that guaranteed income in the future.
How you on the internet with these things?
You
I had that same thing in the wall.
double click. Okay, so
I've turned on all kinds of stuff.
yeah. Let me just double check what most of them are, if they're forward or back. Looks like most of them are pushed towards the line.
Okay.
So it's, you're pushed towards the line and nothing's happening?
No. it's just-
Forward?
Yeah.
The line, the line forward needs to go. It might be like disabled through the system. I'm sorry, I don't know. You're going to do that so you can save the file or something?
Yeah.
Do you have a jump drive you can put it on?
I think I might.
Okay, so any questions about what we've done today? Let me take a look at your gradient before you go, and then I will give everyone the 2 delicious, juicy in-class exercise points. Oh, you even did it the equation method. I'm so proud. Great job.
Engineering student.
Yeah. Above and beyond the call of duty. Wow. This part here, though, this is when, did you actually get it solved to
Yes.
4.2, was it
Yes,
decimal?
round.
Oh, don't round. I'm gonna give you back your
Sure,
homework
sure.
too, when I take a look
You
at
have 5 more
these.
seconds.
I think I have it in here.
Here, you can do the same thing on EV.
Awesome. Alright, I thought you were gonna say battery life on this. That makes fast. I'll get my pipe show for you.
Rate will be 0.02.
No, it is different.
And will be what every year is. It's not a payment, so just do comma, comma, to get away from the future value will be given. You are really efficient by using the paper. You don't want to break out a fresh sheet, do you?
Oh, good.
I don't think this is right. These are, yeah, we didn't get to part 2, did we? That's good. That's okay.
You didn't get to it yourself?
You got too hung up on the calculator thing. Well, love for your time.
No, you're talking about this.
The paper gradient solutions,
I do it by hand.
you didn't do it by hand?
I was trying to be safe.
You got it by hand there? You got the paper gradient solution? Oh, plus 10 equals. I hand back your work, I wanted to show you one of your classmates' solution to part A. It's so thorough and beautiful, I just thought that it deserved a little bit of attention. Here. Oh gosh.
Is that that one? I thought you said part A.
All right, check this out. This is the one where you're estimating how much it costs.
Great.
I'm sorry.
Set the bar high.
I called it.
I missed something though, I realized later.
So some of the solutions were, you know, okay, just saying, well, like 50 cents for the washer, 50 cents for the dryer, 5 cents for laundry detergent, and you know. So in this solution, the student went so far as to calculate the washing machine and the cost of water in a lot of detail, the gas that goes into heating the water, the electricity to operate the machine. Where are we here? Detergent, fabric softener, and then like dryer, cost of utilities associated with operating the dryer, the gas to use the dryer.
Good job, Andrew.
Fabric sheets, you gotta put that laundry somewhere with a laundry basket, added it all up. And then how did you figure how long these things are gonna last? Like a machine, a washing machine, how did you distribute that, the cost of the washing machine?
I never distributed, the second one is no washing dryer,
Yeah.
like you don't need to purchase it.
I see.
And then the bottom one below that is if you didn't have, like you already had the product and you just broke it down even further.
So I thought that was a really detailed solution, and I wanted to show you what a full 5-point solution looked like on that. Alright.
I think you should get an extra point.
Yeah, well, it's in the back of my mind. If he needs that extra point, it just might be there.
That last quiz.
He doesn't need it, which is likely. If you're going to take an hour and a half to solve a 5-point problem about laundry, you're probably going to figure out how to solve the PMT function, or eventually figure out how to use a TI to solve the thing.
TI inspired.
Aaron, Josh. How is it that we just fly through 2 hours and 15 minutes, we use every second of it? We just keep busy the whole time, don't we? It's a beautiful thing. Let's pull up the announcements real quick, just in review. Remind ourselves where we're at. You got a homework assignment due tomorrow. Wow, that came up fast. You've got another one due on Friday. I handed that out to you just to have in case you like to start early. And then organize your papers because you've got an exam on Friday. You can't bring the book for the exam. Well, you can bring it, you just can't use it. You can use an equation sheet. You can use your homework assignments, in-class exercise, notes. So you can use everything except the book. And the reason why I do that is I want you to at least feel like you have to write down the equations from the book onto a piece of paper. That'll force you to study. Another thing you can bring is that equation packet I gave you last time. And then after the exam is over, we'll have 80 minutes for the exam, and then we'll start talking about the project that you're doing for the class. So any schedule questions? All right, then I will see you tomorrow morning. Remember to turn off the laptops. Don't just put them in the standby. Actually, turn them off.